Okay, Assalamualaikum. My name is Nur Amizah Nadia binti Muhammad Ambrose. My number matric DN 2022. Our group title is 5G Antenna Design. Okay, this is my group members, which is Nur Amira binti Anwar. Number matric DN 2038. Second, Nur Amiza binti Anwar. Number matric DN 2033. And lastly, Tava Nisha, anak perempuan Suresh, nombor matrik CN220323. Okay, I will conduct for part introduction. Okay, 5G. 5G is fifth generation mobile network technology, enhancing wireless communication by providing faster data, transfer speed, lower latency, and increased connectivity. It supports the growing demand for seamless communication and enhanced digital life, including faster download, smoothing streaming, healthcare, and transportation. 5G also lays the foundation for the Internet of Things (IoT) and smart city initiative. Okay, for antenna are essential in wireless communication, facilitating and transmission and reception for electromagnetic wave. They play a crucial role in various technology, including radio, television broadcasting, mobile communication, and satellite system. Antenna acts as intermediaries between electrical signal and the electromagnetic spectrum, converting energy into radio wave and transforming received wave back into electrical signal. Their diversity in design caters to specific communication needs, with directional antennas focusing in specific direction and omnidirectional antenna broadcasting in all direction. Okay, for microwave link are essential in modern communication networks, serving as wireless transmission method over short to medium distance. Operating within the microwave frequency spectrum, they use electromagnetic wave to establish point-to-point connection between two locations. They are primarily used in telecommunication for backhauling, ensuring high capacity and reliable connection. Their efficiency lies to transmitting data at high speed with minimal latency, making them crucial for communication infrastructure. Microwave link also find application in broadcasting and enterprise communication, contributing to the establishment of robust and resilient networks.
Hi friends, I would like to present about propagation study, microwave link. Propagation studies of microwave links involve analysis how electromagnetic waves propagate between transmitting and receiving antennas. These studies are crucially for designing and optimizing wireless communication system like satellite links, radar system, and point-to-point microwave links commonly used in telecommunication. For propagation study, several factors affect microwave propagation. That is a five. First is free space path loss. Second is atmospheric attenuation. Third is multipath funding. Fourth is Fresnel zone clearance. And last one is earth coverage and refraction. For 2.2, to study microwave propagation, that is a four. Field measurement, computer stimulation, predictive models, and last one is link budget analysis. That's all from me. Thank you.
Next one is antenna characteristics. Antenna characteristics refer to the fundamental properties that define the performance of an antenna in transmitting or receiving electromagnetic signals. Key characteristics include gain, which measures the antenna's ability to focus energy in a particular direction, bandwidth, indicating the range of frequencies the antenna can efficiently handle, polarization, specifying the orientation of the electromagnetic field, and impedance, representing the matching of the antenna with the transmission line. Additionally, the radiation pattern describes how the antenna radiates energy in three-dimensional space, while directivity quantifies its concentration in a specific direction. These characteristics collectively influence an antenna's effectiveness in various communication applications. Next one is antenna datasheets. There are few specifications taken in designing our antenna. We have general information, electrical specifications, mechanical specifications, radiation pattern, material information, and environmental characteristics. The first one is general information. For the antenna type, the type is omni antenna. The frequency range is between 2.4 to 2.5 gigahertz. And the intended polarization is linear. Next one is electrical specifications. For the gain, we choose 5 decibels isotopic, and the SWR is 0.5 to 1 across the frequency range. Bandwidth is 100 megahertz and power handling is 20 watts. Next one is mechanical specifications. The dimensions of our antenna is, for the height is 50 cm, for the diameter is 5 cm. The weight is 150 grams. The connector type is N type, and the mounting option is mesh or wall mount. Next one is the radiation pattern. Since our antenna type is omni, so the type for radiation is omnidirectional. The beam width horizontal is 360 degrees. For vertical, beam width is 45 degrees. Next one is material information of our antenna. The radar material is UV resistant ABS plastic. For the antenna element material is copper. And last one is environmental characteristics. The operating temperature range for our antenna is negative 40 degrees Celsius to 70 degrees Celsius. So the antenna can use in that temperature range. And the weather resistant is IP65 rated. Next one is antenna parameters. The first one is the transmitted power, PT. The transmitted power for the antenna is 20 decibels milliwatts. Next one is transmitting and receiving antennas with gains, which are GT and GR. For both GT and GR are 5 decibels. And then frequency. Frequency is 2.4 gigahertz. The wavelength is 0.3 meter. And next, distance between antenna 1 and antenna 2 are 100 meter. And then height of the antenna from the ground is 20 meter. And after that, pass loss. The pass loss is 70.04 dB. For pass loss, there is a calculation involved. And the calculation is 20 log distance plus 20 log frequency plus 20 log 4 pi over speed of light minus GT minus GR, and the answer is 70.04 decibels.
Assalamualaikum. My name is Nur Amiza Bidanwan. Next, I will explain about the HFSS simulation. So, in this project, strategic decisions were taken during the design of the pitch antenna to guarantee peak performance in line with certain application requirements. In order to retain efficient wave propagation while still obtaining a small design, a dielectric constant of phi was used. This value falls within the usual range for patch antennas. A standard dimension that is important in establishing the physical thickness of the substrate and affecting the resonant frequency and bandwidth is the dielectric height, which was selected in this project to be 2.5 mm. Resonant frequency then of 2.4 GHz is chosen in accordance with widely used standards for wireless communication. Through HFSS simulations, the efficacy of these design parameters, which offer a strong basis and facilitate insight into radiation patterns, impedance matchings, and other performance metrics, was verified. In order to optimize the antenna's performance and guarantee that it satisfies particular application criteria, adjustments were performed repeatedly during the simulation process. With its realistic simulations, strong optimization tools, and intuitive interface, HFSS offers a solid platform for patch antenna design and optimization. These features all work together to promote successful and efficient antenna design procedures. Next is the S-parameter plot for return loss. S-parameter plot, also known as scattering parameter plots, are graphical representations of the complex scattering parameters, S parameters of a device or network. S parameter describe the linear behavior of a two-port network in terms of how it scatters electrical signals. In this context of antennas, such as microstrip pitch antennas. These parameters are essential for understanding the performance of the antenna. So in this project, S parameter plot is showing the return loss of the microstrip pitch antenna in the S11 plot. S11 plot is a plot of S11 versus frequency. It represents the reflection of coefficient at port 1 and is often referred to as the return loss. A lower S11 value indicates better matching and less reflection. So return loss is a measure of how much power is reflected back to the source in an antenna system. In the context of a microstrip patch antenna simulation, return loss can be obtained by simulating the antenna's performance and analyzing the S parameters, like in this S parameter plot graph. Lastly is the radiation pattern of the patch antenna. The radiation pattern of a microstrip patch antenna illustrates how electromagnetic energy is emitted or received in free space. It typically takes on a donut-shaped form and is characterized by the E-plane and H-plane patterns. The directionality of the pattern influenced by the antenna's dimensions, substrate properties, and feed point location determines whether the antenna is more focused in specific directions or exhibits omnidirectional characteristics. Key features of the pattern include the main lobe, representing the region of maximum radiation to the desired direction, and side lobes, smaller peaks appearing in other directions. The beam width, which measures coverage in a specific direction, and the polarization, either linear or circular, are crucial parameters. Engineers use simulations and measurements to optimize microstrip patch antennas for applications requiring specific radiation characteristics, ensuring efficient communication in desired directions with considerations for gain, directivity, and efficiency. Thank you.
Okay, the integration of microwave link, 5G technology, and antenna design demonstrate the evolution of modern communication system. Okay, microwave link provide reliable high capacity transmission channel over short to medium distance, contributing to network resilience. For 5G technology, enhance data transfer speed, lower latency, and increased connectivity, paving the way for faster and more efficient communication. For antenna, essential interface between electrical signal and the electromagnetic spectrum, adapt to specific communication needs through direct directional or omnidirectional transmission. The synergy of this component highlight the complexity of technology underpinning our interconnected world. and emphasize the need for continued exploration and understanding in the ever evolving landscape of communication system.